This video just contains a few more examples of probability from your notes. So on your way to community college each day, you approach a traffic light at the corner of College and Main. You observe that when arriving at the intersection, the light is green about 35% of the time. So I always just kind of record my probabilities, and I always switch to decimals. And yellow, 4% of the time. And that's all we're told. Well, if I think about a stoplight, it's going to be red. Well, what part of the time would be red? Well, I'm going to have to subtract from 1, right? So 35 and 4 is 39%. So 1 minus 39% is 61% of the time you're going to hit a red. All right. So what's the probability that the light isn't red? I mean green. Struggling to read here. Not green, so proper notation would be green complement. So not green would be yellow and red together. So that's going to be 65 or 0.65. What's the probability that it is red? Well, we just figured that out a second ago, 0.61. What's the probability that the light is red on both Monday and Tuesday? Well, Monday and Tuesday is going to tell me to multiply, as long as, of course, these are independent events, which I'm assuming they are. Monday would be 0.61 and Tuesday 0.61. So I'm going to multiply those and I get 0.372. I'm going to go to nearest thousandth. What's the probability that you don't hit a red light until Wednesday? So you don't get red, so this would be not red, or red complement, and then red. Well, not red would be green and yellow. So that's 39%. So 0.39 times 0.39. And then probability of red, we said, was 0.61. So multiply. And to the nearest decimal, I get, or nearest thousandth, excuse me, 0.093. Okay, what's the probability that you stop at least once during the week? Okay, so at least once, well, gosh, that could mean you stop one time, and it could be that you stopped on Monday, or maybe Tuesday, or Wednesday, or Thursday, or Friday. I'm just talking about a 5-day week since we're talking college. Or it could be that you stop twice, or 3 times, or 4 times, or 5 times, so there's a ton of probabilities you'd have to calculate. But when you see this phrase, at least, it's often easier to think about the opposite scenario, or the complement scenario is really what I mean to say. So if you go to a stoplight, you might hit red 0 times, 1 time, 2, 3, 4, or 5, right? So at least once would be 1, 2, 3, 4, or 5 times. So you could find all those separate probabilities, or let's just hypothetically say, if you knew the probability of not hitting it was 5%, that means this over here has to be 95, right? Because it's got to add to 1, or 100%. If this were 2%, then over here this would be 98%. So let's think about, well, what's the probability of 0? I'm just making these things up. I wrote in yellow. But probability of 0, if I could find that, then subtract it from 1, I'd have what I need. So the probability that I stop at least once, or the probability that I stop greater than or equal to 1 time, is equal to 1 minus the probability that I don't stop, or stop 0 times, right? So this would be 1 minus, what's the probability that I don't stop? Well, I've got 5 days. So I'm going to open up 5 cents of parentheses to multiply my 5 probabilities together. Well, not stopping would be, I'm going to count that as green or yellow, which would be 0.39 if I add green and yellow together. So 0.39 each time. So if on my calculator I do 1 minus 0.39 to the 5th. This is very likely to occur. I get 0.991. Yeah, think about it. Stop at a stoplight at least once during the week, very likely to happen. All right, next I have some probability assignments. It says the plastic arrow on a spinner for a child's game stops rotating to point at a color that will determine what happens next. Which of the following assignments are possible? Explain what's wrong with the others. So this is assignment A. Here is like a spinner, okay? All 0.25, I check, does that add to 1? This one's cool. B, again, this would be 0.3, 0.6, and it adds to 1. That's a fine assignment. Next one adds, nope, this one's no good. Why? Because the sum is greater than 1. That's not okay. D is fine. It would be a very boring game for a kid. You'd have a spinner where the only color on that spinner is green. So, yeah, I don't know how fascinated children would be. It'd be a very poor seller. E is no good either. I see a negative probability. I see a probability greater than 1, so not good. Okay, so number 9 is very similar to the setup of number 7. So I think you should try this one without my assistance. Hit play when you're ready to check your answers. Just one clue would be, just like with the stoplight, list your probabilities off on the side before you even start answering questions. Hit play when you're ready. Okay, so from reading this, my probabilities that I notice are no calculus is 55% or 0.55. 1 semester of calc is 0.32. And it says the rest are 2 or more. So I'm going to say 2+ semesters. Well, if I add 55 and 32% together, I get 87. So take that away from 100, I'm missing 13%. And now I'm going to go answer the question. So 2 or more, well, just got that. That's the 0.13. Some calculus. Well, some calculus could be 1 semester or 2 or more, so it's going to be these two added together. So if I put 0.32 plus 0.13, that is 0.45. And then no more than 1 semester of calculus. This is the probability that you're less than or equal to 1. That's what no more than means. So that's going to be adding the 55 and the 32, and that is 87%. Okay, similar but yet a slightly different scenario, because in 10, you're assigned to be part of a group of 3 students from the Intro Stats class. What's the probability that the other 2 group mates are? Well, I've got 2 group mates. I'm assuming that whether a student has calculus is independent from another student, so that neither has studied calculus. Well, neither means no calc, so that's 0.55 for the first, 0.55 for the second. Since they're independent events, I multiply that together, and that gives me 3025. Both have studied at least 1 semester. So at least 1 semester would be, at least one would be 1 or more. So this would be these 2 numbers together. So 0.45 for each. Okay, our final scenario, at least one has had more than 1 semester of calculus. Okay, there's a couple ways that this can be done. All right, I'm going to do it actually, I think, the long way first, because it may be easier to understand. So I've got 2 students, first and second, and probability that at least one of them has had more than 1 semester. So more than 1 would be 2 or more, or 0.13. So maybe the first kid and then the other kid had none, or 1, or just the complement of that. In other words, that would be these 2 added together, the 0.87. Okay, but maybe it is the second kid had 2 or more. So the first kid had none or 1, and the second kid had 0.13. Or maybe both of them had more than 1. So that would be 0.13 times 0.13. And that gives me 0.2431. Okay, so that's the first way of doing this. The other way, when I see that word at least, makes me think about the complement. So it would be equivalent to, rather than at least one, it would be the probability that no one had more than one semester of calc. So the probability that no one had more than one semester of calc, that's easier to compute. That would be these two together, the 0.87. So 0.87. So if I do that on my calculator, I also get the 0.2431. So your choice on which way you prefer, just kind of depends on what you, I think the second way is easier to calculate, but sometimes it's conceptually harder to understand. All right, reach out with questions.